Now let's look at how to calculate binomial probabilities on the calculator. There are two distributions on the calculator under Menu, Statistics, Distributions, and you go down to choices D and E, which are pretty far down the list. Binomial PDF and binomial CDF. The parameters of a binomial model are n equals the number of trials, p equals the probability of success, and x equals the number of successes. So we use binomial PDF, probability density function, when we have exactly x successes, and we use CDF when we have a range of from this many to this many successes. So let's take a look at some examples of how to do this on the calculator. One thing is, just like with the normal probabilities, we do the computations on the calculator, but we are expected to identify the model that we're using by its name and by its parameters. For the normal model, we identify mu and sigma, and we say it's a normal model, and we make that little sketch. For the binomial model, you're not making a sketch, but you do need to identify n and p. And for right now, because you are going to need to be familiar with the formula, potentially, I want you to use the formula as well. You don't have to use it to calculate, but you need to. I would like you to set it up. So here's what you would do for something like this. So for the tongue rollers in the elevator example, we're going to use the binomial model with n equals 8 and p equals 0.7. So this is going to apply to all these examples, but that's how I would identify that I'm using the binomial model, and those are the parameters. Then I would say, what's the probability that 4 people out of the 8 can roll their tongue? So this is the probability that x equals 4. So I would set up the formula as 8 select 4, 0.7 to the 4th, 4 successes, 0.3 to the 4th, 4 failures. Now on the calculator, since this is exactly 4, x equal to 4, I would use binomial PDF with these parameters. N equals 8, p equals 0.7, and x equals 4. So let's see what that looks like on the calculator. So on the calculator, you go to Menu, Statistics, and you go to Distributions, just like you do for a normal CDF, and you're going to go down till you get to these choices down here. So you see here's the binomial PDF, and right below it binomial CDF. It just gives you a place to put in number of trials, probability of success, number of successes 4, and there you go, 0.136. Okay, what's the probability that less than 4 people can roll their tongue? So the probability that x is less than 4, remember this is a discrete probability distribution, so we have to say that's the same as the probability that x is less than or equal to 3. And remember that x can be 0, so we're looking at the probability that x is from 0 to 3. Showing the work for this is I would start with setting it up for 0. 8 select 0, 0.7 to the 0, 0.3 to the 8th, plus dot dot dot. Set it up for the last one. 8 select 3, 0.7 to the 3rd, 0.3 to the 5th. Once again, I'm not going to use the formula to do the actual computation. Now I'm going to be using binomial CDF, cumulative density function, with n equals 8, p equals 0.7, and then I'm going to have my low 0 and the high, and I'm not sure what it actually says in the calculator. We'll look in a minute. It might say left and right, like it does for normal models. So when we do binomial PDF, so we're going to go to Menu, Statistics, Distributions, and go down into normal CDF, or binomial CDF. Oh, lower bound and upper bound. So we have 8.7, 0 to 3. Okay, and so that's 0.0579. That's good enough. So equals 0.0579. So I'm not writing a sentence here, but basically I would say there is about a 6% chance that less than 4 people in the elevator can roll their tongues. So you can write a sentence for that. Definitely answer the question when you are doing this. What's the probability that at least one person can roll his or her tongue? And there's actually two ways you could do this. I remember that the probability of x greater than or equal to 1 is 1 minus the probability that x equals 0, because that's the only one I'm leaving out. So I could do that. So this would be 1 minus binom, and then I would use the binom PDF for 8.70. Or I could say the probability that x is greater than or equal to 1 is equal to, and I could just, this one I could use the binom CDF, and I could do 8.8, I don't know why I put a point there, 8.71 to 8, okay? Either one of those would give me the same answer. So I'm going to just kind of go through the process of that. So I'm going to just select this, just go ahead and edit this. So I can just change this to 0 and then do 1 minus this. So 1 minus this one. Or I could do the CDF and go from 1 to 7. Or sorry, 1 to 8. Okay, same thing, 0.9999. So I didn't set the formula up for these. This is 0.999934. Okay. If I did the second one, I would do 8 select 1, 0.7 to the first, 0.3 to the 7th, plus ... plus 8 select 8, 0.7 to the 8th, 0.3 to the 0. And I wouldn't actually have to put 0.3 to the 0. So right now, I would like you to show, I would like you to name that's a binomial model, say what n and p are, use the probability notation, show the formula, but then use the formula use the function on the calculator to do the actual probability. Now, something else that's interesting that you can do, I'm not sure that you would ever be asked to do this on the AP exam. Probably, I would say definitely you would not be asked to use your calculator to do this, but the PDF also gives you the option of creating a probability distribution. So what I did on my calculator, and I'm just going to show you what I did here, is I put in the number of rolls, all the possible number of rolls here, 0 through 8 in this column. And then I created on the probability, what I did was, and I'll kind of expand this so you can see here, is I used equal, the formula, binom PDF 8, 0.7. So when I did this on my calculator, menu, statistics, distributions, oh, for some reason it's graying out the distributions. Okay, escape, escape. Okay, menu, statistics. Okay, now it's going to let me do distributions. And then go down to binomial PDF. What I did was I put in 0.8 and 0.7, but I left the X blank, which says optional. And what happens then, and I push enter, and it populated this list with all the probabilities. So I have a probability, the binomial probability for each one of these outcomes. And then I use that to make a probability distribution. So here would be the number of rolls, and then I used this as a Y summary value, and I have this histogram. And if we go back and look here, then you can see then if I were to highlight any of these bars, it tells you this bar goes from 6 with a square bracket to 7 with an open bracket. So this is the bar when X is 6. So the probability of getting exactly 6 rolls, as we saw earlier, was 0.2965. And you can see it's somewhat shaped, somewhat symmetric in shape, slightly skewed to the left because there would be a very small probability of 0 and 1, which barely show here. You can see if we thought, what are the mean and standard deviation of the model? It looks like the mean in the middle of the model would be maybe around 6, somewhere pretty close to that. The standard deviation, we see that it's a little more skewed this way, but maybe maybe about 1, you know, 1 or a little more than 1, the standard deviation. If you think about Since this is somewhat normal in shape, we could think of plus or minus 3 standard deviations. So plus 3 standard deviations would be 3 over here and 4 over here, so probably around 1. But how do we actually calculate the mean and standard deviation for a binomial model? Once again, this is on the AP formula sheet, and it's defined. Mu of x for a binomial model is n times p. Sigma of x for a binomial is the square root of np times 1 minus p. So n times p times 1 minus p. So for our example, in the elevator example, and with the tongue rolls, where n is equal to 8 and p is equal to 0.7, we would have mu of x is equal to 8 times 0.7, which is 5.6. So 5.6 people on average are expected to, 5.6 out of the 8 people on the elevator would be expected to be tongue rollers. And that looks pretty reasonable for this distribution here. Sigma of x is equal to the square root of 8 times 0.7 times 0.3, which turns out to be 1.296. Once again, not unusual for our distribution. It looks very reasonable. So that's how you find the mean and the standard deviation. So once again, the mean would be the expected number of tongue rollers in a group of 8 with this probability of being a tongue roller, and this would be the typical amount of deviation we would expect in a group of 8. From one group of 8 to another if we randomly select people. The last video will tell about one special condition dealing with independence, and then we will be done with the binomial model stuff.